Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to introduce or potentially, hopefully, review the concepts of latitude and longitude. Because again, these are going to be the foundational building blocks to pretty much everything in geographic information science, including the topic of this module, which is map projections. So hopefully this is going to be a review for you, either from high school or hopefully from another course in geography or GIS. But just in case it's not, I think it's really important that everybody has a good fundamental understanding of what latitude and longitude mean and what we mean when we talk about meridians and parallels. Okay. So what I want to do first is I want to simply define latitude. So when we talk about latitude, what we're talking about is the angle created from the center of the Earth to a point on the Earth's surface, specifically in the north-south direction. So what I have here is I have in a three-dimensional sphere, or at least the best representation that I can draw of a three-dimensional sphere. And what I want to do is I want to actually draw latitude in green. So we have this point P, so this would be maybe us standing outside with our cell phone turned on, getting ready to drive somewhere, right? Google Maps is reading our location from satellites. So this might be us standing somewhere. And depending on the settings of your GPS, right, you can get your latitude and longitude. Well, what does latitude mean? So if you think about this, right, there's really two different angles that we need to worry about here with P. Right, one is going to be relative to up and down, or what we would call north-south, right? Because this is the North Pole, this is the South Pole, right? So the first thing that we would need to worry about is the angle made from the center of the Earth, right, along the north-south direction, right? So this angle right here, right? So we call that angle, right? We call that angle latitude. And you will often see it represented when we talk about map projections specifically. You'll often see it represented by the Greek letter lambda. Now, unfortunately, lambda has a lot of other uses, but in the case of map projections, when you see lambda, we're typically talking about the angle relative to the center of the Earth. Now, a couple of important terms to know with latitude. The first is the 0 degrees latitude. Right, so this would be the line that cuts the Earth at its widest point. Right, this is something hopefully we all know called the equator. Okay, so this line right here, right, that's cutting the Earth in half, and you can imagine it going around the back, something like this. Right, that is the equator. Right, it's the line that cuts the Earth in half at its widest point. Okay, so any other line of latitude, right? Lines of equal latitude, right? So for example, granted this is a really terrible drawing, right? But this line right here, right, assuming that it all has equal latitude, right? That right there, that line of equal latitude is called a parallel. Right, a parallel. Okay? So again, Latitude is the angle created from the center of the Earth to a point in the north-south direction. 0 degrees latitude is the equator, which is the center of the Earth, which is the latitude at the center of the Earth. And then any line of equal latitude, north or south of the equator, is called a parallel. Okay. So hopefully that makes sense. So what I've done here in these diagrams is I've actually broken it up. So I've taken so this would be if we cut the Earth in half sort of through the poles. And this would be if we cut the Earth in half through the equator. And you can see that I've put P on the outer edge of the circle here. Okay. So in this case, right, this line right here, this line would be the imaginary line of the equator. And you can see that we're north of the equator. So what we have here, right, just to sort of recap, this angle, right, caused by this triangle, right, this angle right here, right, this is lambda, or what we call latitude. Right? So this is latitude. Right? Again, just to reiterate, right, it's the angle created when you go north or south from the equator. So it's the angle from the center of the Earth to a point on the Earth's surface, north or south of the equator. Okay? Let's talk about, give ourselves a little bit of room here. Let's talk about longitude. Right, longitude. We're going to do this one in orange when we draw it out. Okay? All right, so longitude is the angle. It's going to look very similar. In fact, I'm going to try and scroll up so we can see both definitions. Right? Longitude is the angle created from the center of the Earth to a point on the Earth's surface right in the east/west direction. Okay? So let's go back up here to our example of Earth here. Grab our orange coloring here, right? So the angle caused, so this angle right here, it's kind of hard to see here, but this angle caused right here, this angle right here, right? This is your longitude, right? Longitude. So I think it might be easier to see on our sort of broken out diagram. So this, again, this would be what we would call the line of 0 longitude, which we'll talk about in just a second, right? But the longitude of this point P is going to be the angle, right, from the center of the Earth relative to this 0 degree line. Right, so this right here, this is going to be our longitude. Okay. And now typically with longitude, what you will often see it described as is you will often see it described using the term phi, or sometimes you'll see it referred to as lambda. So this is going to be phi, which looks like this, or sometimes you will see it referred to as lambda. So this is phi. Sometimes you'll see it referred to as phi, and sometimes you'll see it referred to as theta. And now it's unfortunate because you look very similar, especially with my bad handwriting. But the idea is that lambda is latitude, and then either phi, or theta will be used to describe longitude. So in this particular video series, I'm going to be using theta just because I seem to be able to draw that one a little bit better. So we're going to have lambda be longitude and theta be lambda be latitude and theta be longitude. Okay. So let's go back down here and let's do a couple of important terms here. So just like with latitude, right, we had this idea that the 0 degree latitude line was called the equator, right? For 0 degrees longitude, right, what is 0 degrees longitude? Well, with latitude, it made sense, right? Because the Earth is widest at one point as you go north-south, right? Right? If we look at our example here, right, as we go north-south, right, it's skinnier up here, wider here, skinny down here. So it makes sense to pick the widest point as our 0 for latitude. But what about longitude? Right? No matter how we cut it, right, the Earth is always going to be the same circumference. Right? No matter how we cut it. Right? We could cut it this way, we could cut it this way, we could cut it that way, we could cut it that way. Right? Every single line of longitude is going to converge at the poles. So that means every single line of longitude is the same circumference. Right? The great circle caused by the line of longitude is the same circumference. So how do we pick one? Well, what we did is back in the day when we were first developing these sorts of things, we actually just picked one. And it's the line of longitude that runs through Greenwich, England. And we call that line of longitude the central meridian. Okay. Which is Greenwich, England. So just like lines of equal latitude are called parallels, right? Lines of equal longitude are called meridians. Lines of equal latitude are called parallels. Lines of equal longitude are called meridians. Okay. So hopefully this makes sense. Let's just quickly recap what latitude and longitude are. So latitude is the angle relative to the equator, north or south. Longitude is the angle relative to the prime meridian, east or west. So longitude, east-west, latitude, north-south. So hopefully that makes sense. And in the next video, we'll talk about how we can take latitude and longitude and convert it into a two-dimensional representation by talking about the types of map projections. So again, if you have any questions, pause the video, go back, rewatch the part you're confused about, and as always, please reach out. Thank you.